consider stretches or shrinks. We can do this both vertically and horizontally. Let's start with looking at stretching or shrinking the graph vertically. Let's suppose a is a number that's greater than 1. The graph of a times f of x is the graph of f of x stretched vertically by a factor of a. So multiplying the function by a number greater than 1 will stretch it vertically. On the other hand, if a is a number between 0 and 1, then a times f of x will shrink the graph vertically by a factor of a. So numbers between 0 and 1 will shrink the graph. If we have a negative number, we need to perform the reflection, and then we can do the appropriate stretch or shrink. When looking at the table of a function, we can determine the table of the new transformation. Step 1, we need to determine our output row or column. Anytime we're doing anything vertically, we are going to change our output row and column. The next step is to determine the stretch or the shrink factor. How much are you stretching or shrinking the graph? Finally, we need to multiply each output value by the stretch or shrink factor. As an example, let's consider the function given by this table, and I want to know the table of the function given by 2f of x. Our first step, we need to determine our output row or column. Our second step is to figure out our stretch or shrink factor. In this case, we're multiplying our function by 2, and since 2 is greater than 1, this is a stretch by a factor of 2. So we're going to multiply each of our outputs by the number 2. Negative 2 times 2 is negative 4. Negative 1 times 2 is negative 2. 0 times 2 is 0. 1 times 2 is 2, and 2 times 2 is 4. So I have my new table for 2f of x. When looking at the graph of the function, we're going to need to change the y values on the graph. The x values will remain the same, but the y values will be altered depending on our factor of the stretch or the shrink. So as an example, let's consider this graph, and let's suppose we want to know what 1/3 of f of x is. This means we need to multiply each of our y coordinates by 1/3. For this point right here, the output is 1, so my new output will be 1/3. This is 2 times 1/3 would be 2/3. This point right here has an output of 3 times 1/3 would be 1. And we could keep going. But if we do, we get a graph that looks something like this, where it is now shrunk vertically. We could also look at horizontal stretches or shrinks, so stretching or shrinking a graph horizontally. Let's suppose the number b is greater than 1, then the graph of f of bx, so we multiply x by b. This is the graph of f of x shrunk horizontally by a factor of 1/b. If b is between 0 and 1, then the graph of f of b of x will be the graph of f of x stretched horizontally by a factor of 1/b. So just like with my shifts, horizontal stretches and shrinks are the opposite of what we expect. Multiplying by a number bigger than 1 actually shrinks the graph, and multiplying by a number between 0 and 1 will stretch the graph. When looking at the table of the function, we can determine the table of the new transformation. The first step is to determine our input row or column. In general, anytime we're doing something horizontally, we're looking at our inputs. Anytime we're doing something vertically, we look at the outputs. After this, we need to determine the stretch or shrink factor. Keep in mind that whatever we're multiplying by, our stretch or shrink factor is 1 over that. We will then multiply each input value by our stretch or shrink value. Let's consider this table of this function, and we want to find the table of f of 4x. Since 4 is greater than 1, this is going to be a shrink by a factor of 1/4. We do need to determine our input row or column, which is here, and this is what we're going to multiply by 1/4. So our new table, our output row stays the same, and then our input row, -8 times 1/4 is -2, Negative 1 times 1/4 is negative 1/4. 0 times 1/4 is 0. 1 times 1/4. When looking at the graph of a function, we'll need to change the x values of the graph since those are the inputs, and our y values will remain the same. The x values will be altered depending on the factor of the stretch or compression. As an example, let's suppose we want to find f of 1/4 of x. 1/4 is going to indicate a stretch by a factor of 4. So in this case, we're going to take our x values, in this case the x value is 1, and multiply it by 4 to get 4. This one is negative 1, times 4 would be negative 4. So we have our new graph that is now stretched horizontally.